I was surprised to find out a few weeks ago that the ReLU and GELU activation functions are not being used in modern day transformers, but actually the SwiGLU activation function. Let's talk about what the SwiGLU activation function is, the math behind it, and why it gives us these benefits compared to the older activation functions used in older transformer models. So the SwiGLU activation function is composed of two different activation functions, the swish function and the glue function. The swish function is an activation function that is essentially just our input times the sigmoid of our input. So you can see here that this is our sigmoid, obviously, and that's 1 over 1 plus e to the negative x. And you can see we use the sigmoid activation function in a lot of binary tasks because it gives us an output between 0 and 1. However, now we're multiplying it by our input, right? And why is this actually beneficial? Well, this actually gives a lot of performance in a lot of different tasks over the ReLU activation function because it has a smoother transition over 0, which helps for optimization. You see here we have this beta parameter, and this is a learnable or fixed parameter, but most of the times it's just set to 1. So that's why you can almost ignore it and just say that that's a sigmoid activation function. The second activation function is a glue activation function. Now, this is a gated linear unit, and we can see this here as there's two different weights. So W is going to be our first weight matrices, and the V is going to be our second. And same with that, we also have two different bias terms, right? And what's going to happen is we're going to have one linear layer, right? So basically, any neural network without an activation function, this is what it's going to do, right? The dot product of our input times the weights plus the bias. And then we're going to do element-wise multiplication by the sigmoid of this, right? And this is going to cause a gated linear unit, and it's basically going to help as gating, right? So this is basically going to allow the model to kind of choose what information passes. So this is the full SwiGLU formula. You can see it's similar to the gated linear unit, but instead of the sigmoid, we actually have the swish, right? So it is flipped in this formula, but we have the swish. So now it's almost like, as we can see, the swish function is super similar to the sigmoid, except we multiply by the linear layer. Now the swish activation function gives us some benefits in performance compared to ReLU in a lot of different tasks. And now we're also using the gated linear unit, and this is going to allow us to also basically allow which information passes through to the next layer. And that's going to allow us to have a lot of different benefits as it has consistently outperformed ReLU and GELU. It has smoother gradients because of what we said previously with the smooth transition over 0. And just empirically, based on the results, based on tests, it's just proven to be better accuracy. And that's why it's used in a lot of models today, like Llama and Palm.